Good afternoon, everyone, and depending on where you are in the world, good morning or good evening. My name is Hardik Singh, and today I will be presenting on behalf of HEBI Robotics to introduce our robotics development platform for research designed to make your research faster and more effective. My role at HEBI Robotics is that of a product manager, and so I deal with everything between the technology and the customer and how we can narrow the gap between what our customers need and the products we provide. Today, I will be covering an overview of HEBI Robotics and our products. I will talk about our development platform in action as we build a robot for mobile navigation in the wild. And finally, I'll wrap up with how our customers are using our products in machine learning and locomotion research all around the world. To kick things off, let's take an overview of HEBI Robotics and our technology. HEBI Robotics was founded in 2014 out of the Biorobotics Lab at Carnegie Mellon University. As such, you'll find that many of our personnel are researchers at heart. Our main office is located in Pittsburgh, Pennsylvania, with a satellite office in Salzburg, Austria. And this allows us to cater to the over 100 customers we have around the world in 26 different countries. Our goal and our mission is to accelerate the future of robotics. And we do this by providing hardware and software that allows you to build robots quickly and effectively. Some of our customers are listed at the bottom of the screen, and you'll find that the majority of our customers are researchers, both in industry and in academia. As such, one thing we focus on a lot is how we can make the researcher's life easier. And so I'm going to cover the 4 main ways in which we do this. To kick things off, we have hardware, which is that we've made hardware that is tuned to the researcher's needs. The HEBI Robotics platform is centered around 2 main hardware modules, our X series and our R series actuators. We've really tried to compile everything you need into these actuator modules, from integrated sensor hardware, like embedded IMUs, encoders, and control electronics, as well as simplifying the challenge of power and connectivity with standard connections and wiring, such as Ethernet. We've made a compact package that consists more as a full-featured robotic component as opposed to a simple servo motor. While the X series is our base actuator, the R series takes that same power, but also adds the addition of it being sealed to IP67 for the dusty and dirty outdoor environments. To really make the most of our powerful hardware, we have to design software that matches that power. And so what we've tried to do is really tune into how the robotics researcher uses that hardware and what their needs are. We've created custom applications to track the feedback and control commands being exchanged between our hardware and the computer. We have mobile applications that replace the joysticks or PS4 controllers we keep misplacing in the lab. And instead, we've put a readily available joystick right on your smartphone and in your pocket. On top of that, we have simulation tools that work in parallel to our hardware, and we make that experience very similar, so you can switch between that software and hardware very easily. And we support all of this with our 4 main APIs. We have MATLAB, ROS, C++, and Python. All of them have full functionality in their own environment. And so for the researcher, we really want you to be working in the environment that you are most comfortable with to make sure your development is as easy as possible. Putting those 2 things together, we also find that you don't want to be worrying about building a robot out from scratch. So we give you a starting point using the variety of kits that we have on offer. This is popular for researchers on all ends of the spectrum, whether you are a mechanical engineer hoping to work with user-friendly hardware, or a software engineer who wants to focus on sophisticated software challenges instead of building the platform from the ground up. These robot kits are pretty popular solutions for researchers to get up and running quickly. But because they are modular, they're also a popular solution to purchase and then reconfigure as per your needs. One way or another, this still saves you a lot of time in getting to a system that fits your research. To tie it all together, we have a wealth of documentation to make sure you can maximize your use of our tools. We have a documentation page that you can check out right now, as well as a YouTube page with videos of our demos, GitHub. We host webinars every so often. And not only does this documentation cover all aspects of our platform, in addition to that, we are building a HEBI community of researchers and developers around the world who can share their work and collaborate to accelerate their speed of research and development. And so putting this all together, we really have a comprehensive platform designed to make research easier and accelerate that speed of research. Given my current audience, however, it would be wrong for me to move on without at least explaining why this platform is useful for machine learning researchers in specific. And I will do that a little bit later as well when I talk about how some of our customers around the world are using our platform. First and foremost, we want to create a platform where you do not need to worry about the hardware. We have a system that you can work with and that is easy to use, regardless of whether or not you are a hardware engineer, software engineer, ML engineer, and so on and so forth. Any code that you write and models that you train in simulation can just as easily be run on the robot with minimal changes to the code. we've tried to make it seamless to switch between software and hardware, or rather simulation and hardware, when it comes to working with the robots that you're doing your research on. Flipping that around, our actuators collect all types of feedback during live operation as well. So even when you're running the robot in the real world, you can get all the data you need to tune your model parameters in simulation. And so whether it's individual position, velocity, and torque commands, or the control gains set at each joint in your system, you can go from simulation to hardware, but also get the data you need from hardware to simulation. And as we know, one of the most useful things about doing hardware research is that you need real world noisy data that you can then train your models on and test your models on after you've run them on simulation. So we really want to make sure that we can continue to help you apply your research to the real world. Shifting gears a little bit, let's take a look at what that platform is like in action. More specifically on a recent project HEBI had in which we built a robot for navigation in the wild. The proposed challenge that we had contains a lot of the common challenges that mobile robots face in the wild today. In this case, it was landslide search and rescue, but the focus was on slopes with rocky and unequal terrain, such as what is pictured on the right side of the slide. This meant that we had large, non-uniform obstacles. We were dealing with an outdoor environment with unequal stairs and inclines to climb. And these inclines and slopes could get pretty steep, in some cases up to 75 degrees of slope. On top of all this, we also had to carry a payload of sensors to map the area, and we had to facilitate remote teleoperation and manipulation. This in general is a pretty hard challenge. And to summarize that, we have a difficult terrain where even the most sophisticated robots struggled. In fact, the customer that we were working with wasn't able to find an off-the-shelf solution that worked for them after having tried a few of those solutions. And that's when they approached us, because what we can do is that in the space of just 6 weeks, we can put together a robot in a whole new form factor. And these tools are not just for us, but also for all our customers in our platform as a whole. This was not a common form factor, but what we did was we quickly assembled 2 bodies for the robot using a T-slot extrusions, our actuators, and some of our common accessories. We were able to easily 3D print any brackets that needed any customization. And what we did here is we created those 2 bodies and we provided a link in the middle, which was actuated from both ends. So this is a pretty atypical form factor that we could create because we had our Lego-like modular actuators. And we believe the system could do well, but the best way to find that out is to get testing. So by the 3rd and 4th week, we were running tests inside our office in Pittsburgh. And you can see here how the simulated slope that we created, it was a 50-degree slope with steps that were roughly a foot apart. Our robot was able to do it with a few modifications. And once again, those modifications were easy for us to do. But being able to do this in the office helped us confirm before even going outdoors that our robot had a good chance of taking on the outdoors. And so the next step, as you may have guessed, was to take the robot outdoors. Not only did we do that, however, we also added a few more configurations to really close the loop on what we wanted our robot to be able to do. We added 2 arms, which both, one was a 3-degree of freedom arm for camera articulation, and the other one was a 6-degree of freedom manipulation arm. On top of that, we were able to, because we were adding so much payload, we were able to change out the actuators at the wheels and the tracks to be stronger actuators. And that modularity, once again, came in from the fact that our platform facilitates that switching in and switching out while keeping the challenges of power and connectivity the same. Finally, to wrap that up, we even have the software that we didn't have to program anything new. We could just pull it right out of our code repertoire that you can find online on our GitHubs. It may look like the robot was ready to take on the challenges, and it was, but if you're really pushing the limits of what research can do, then you'll usually find that things don't always go according to plan. And you can see here what that looks like in real time. The robot had a little bit of a tumble, but that's what happens in research sometimes. And so the essence of moving quickly is the ability to not let things like this or events like this stop your development. What this means really is that we were back in action in no time after one overnight print for some new brackets, a retightening of some screws. And the very next day, we were out there tackling new stairs, tackling new slopes, and our platform allowed us to really reduce the downtime that we were facing and focus more on the challenges that came after building the robot, which includes the software, the navigation, and the quality of data that our sensors can collect. And so we're really trying to reduce the downtime from the different hurdles that we as researchers face. Putting that all together, if you really think about it, in the 6 weeks that we took to put the robot together, our research was still only really just getting started. That being said, we could still continue to iterate the design as needed with the same set of hardware. You can take out an actuator, put it somewhere else in the robot. The T-slot extrusions allow you to move lengths around, and you can really reconfigure as you need to go. And on top of that, the feedback and control we were receiving at each joint, combined with all the data from the built-in encoders, the IMUs, really gave us a lot of data to learn from, but allowed us to implement more complex algorithms as we learned more about the application, more about the challenges, and really continued that life cycle of research. And on top of that, you can see here that I have an image of a different but similar robot on the bottom right. Whether it is about changing form factor or whether it's about adding sensors, adding arms, adding cameras, our platform is designed to facilitate all of that. And so our project continues to this day, and hopefully I'll be able to talk about the next steps of that project in a future presentation. But right now, I'd like to shift over to talking about some of how our customers in industry are using our platform as well. I'd like to start off by talking about Facebook AI, who is a research group at Facebook using our platform to teach AI how to walk with legs. They're using model-based reinforcement learning methods without being given task-specific information or training. And these guys were a set of ML engineers who didn't want to be building a robot to test their algorithms. They just needed a robot off the shelf, but also one that had stability in 6 different legs and one that had a more exciting form factor. And so all these things were really worked out for them because they got an out-of-the-box solution for tackling those sophisticated machine learning challenges by using one of our standard robotic kits. On a similar front, we actually had Google DeepMind also trying to learn how to walk, but doing it in a more generalized approach. They were looking for generalized locomotion, and in that they were looking to design a framework that could learn sophisticated locomotion behaviors for a wide spectrum of legged robots, as well as their wheeled variants. The low-level access of our platform allowed them to create a variety of different form factors, as you can see on the bottom of the slide. And each of these form factors could then be tested in simulation using their generalized framework. But most importantly there is that they were able to then take that simulation from that work from their simulation and put it on a real hardware. That four-legged, not hexapod, but quadruped that you see the pictured there, that's not a standard kit we provide. But they were able to take a kit that we do provide and configure it to their needs. And so that low-level access to sensor data at a joint level gave them a reconfigurable system to really test and collect the appropriate data. And finally, we also have NASA Ames Research Center, who dealt with an even larger problem of trying to come up with a whole new locomotion method altogether. You may have seen this tensegrity robot out on their website, but this was, I believe it's called Super Ball V2. And it's a robot designed as a novel locomotion method for space exploration. They took our actuators as Lego pieces, and they created new robots quickly to take on the challenges of unfamiliar environments. And that's something we're going to have to keep being able to do as we explore more and more of the unpredictable environments of the wild. And this was one way in which NASA did that. And so to wrap up my presentation, as I see I am running a little bit short on time, in summary, HEBI Robotics makes tools for the researcher to make robots quickly and effectively. We allow you to work in the software API of your choice, with a robot of your choice, on the challenges of your choice. We do everything we can to cater to the researcher's needs and how we can make the researcher's life easier, as many of us have been there in the past as well. What we really want is for you to not worry about the hardware, but still have access to expert motion control. There's an infamous saying that we've heard in the research community: adding hardware to my project will add another 1.5 years to my degree. Well, the work we do as a company challenges that very notion. And for many of our customers, we have turned that theoretical 1.5 years into a matter of weeks and hours. And so we really strive to make sure that you don't have to worry about the slow things, and you can focus on your sophisticated research in robotics instead. And this is how we facilitate a global community of researchers working together to truly accelerate the future of robotics. I'd like to thank everyone for your time today. If you'd like to learn more, you can come to hebirobotics.com, as well as check out our videos on YouTube to see our platform in action. We are researchers, as I mentioned, so if you have any project that you think we might be able to help with, please feel free to reach out. We love hearing about your projects, and we love being able to figure out new ways our platform can be a better fit. And last but not least, I'll add a quick note that we are hiring a sales and application engineer in the form of an evangelist who loves our platform and can help us expand our customer base to grow the HEBI community, all while playing with our robots. I'm now open to any questions, and I'd like to thank our hosts for having me.